everybody. Yeah, like Dylan said, my name is Olive. I use she and they pronouns. And for the last year, I've been working on a video game. Last March, I kickstarted a video game to convert this tabletop RPG made by Tom Bloom and Miguel Lopez into a kind of like Baldur's Gate-esque, like, it's not like Baldur's Gate, but it's just like converting a TTRPG into a computer game. I was able to do this because it has a really open third-party license. And I sent them an email and I was like, can I actually do this? And they're like, yeah, go for it. And so it turns out that it's a lot easier to make a game when you use somebody else's like existing IP rather than like starting from zero. But that's another talk. And so Lancer, just to like kind of give you a idea of the scale, is a very crunchy game. There's tons of unique abilities. There's like 28 different possible player mechs, which kind of like function as character classes in D&D, and a whole bunch of NPCs that like also have like their own deals going on. And everything's like mixed and matchable. So like an ability from like one mech can be applied to another one, just kind of like all willy-nilly. So I have needed to be very careful and very thoughtful about like how I'm building this engine to like set myself up for the next couple years of development. And you can kind of see here that there's the like complexity of the abilities like range really widely. Like there can just be like a big sword that has like a couple keywords, like different damage types, and then like special tech abilities which like have paragraphs of information and like custom like events and things that need to happen. So I definitely bit off a lot to chew. So after about a year, this is what the game looks like currently. I've been just like updating this flowchart to like keep track of everything. And I know that it looks like a lot, but what I'm here to talk to you about today is kind of like the organizational principles that I've been following that makes this not too much of a nightmare. And those things are three different like layers of things here. Up at the top, we have stateless resources. In the middle, we have persisted resources. And then at the bottom, we have ephemeral nodes. And I had that kind of like, wild title because like each of these layers feel very different to me. The stateless resources at the top feel very like ephemeral, or not ephemeral, but like kind of like divine, like they're up in the heavens. They don't have any state. Like they just kind of like do an event with the stuff that you pass in, and then they like forget all about it. The stuff at the bottom, like the ephemeral like nodes, feel like very earthy to me because that's like very like front end stuff where it's like, okay, I'm just gonna make like a particle effect, and like it'll like blast on the screen and then it'll go away, and I can like throw it away. And that also goes for things like character tokens or like map icons and stuff. All of it is just kind of like, it comes and goes, and like it doesn't have like any state. We don't have to care about like throwing it away and making new stuff. And then the things in the middle, the persisted resources, feel kind of like spirits or ghosts to me, because they have long memories. All of your state lives there that you care about, but they can't do anything on their own. Like they're very lightweight. They're just kind of like data repositories. So I'm going to go through each one of these more in depth to kind of like tell you more about like what they mean. So we're going to start with stateless resources, that top layer. I realized halfway through yesterday that like I've been describing them as functional programming, and they're definitely not. Like functional programming, just like in case you don't know, means that a function, you give it parameters, it does stuff to it, and then it returns a value and it has no side effects. You can be sure that like every time that you run it, it's going to do exactly the same thing. When I am talking about like these stateless resources, they might have side effects. And so for instance, in this kind of like passive stat increase ability here, you can see that it's passed in a bonus and then it has like an increase that you've already set, and then it just like implies that increase to that bonus. And so like it doesn't remember that it's done this, and that's what I mean by stateless. So in Godot, what this kind of like passive stat increase ability would look like in the inspector would just look something like this, where you're setting something up. It's like, okay, the stat block, or this increase here could increase like any of these values, and in this case, it just like increases armor by 1. And these are really useful in kind of like setting up like these abstract abilities, where it's like, okay, I don't know what this is going to get applied to, but this ability always like increases your armor by 1. You can also use these stateless resources to do more complicated things, or like more unique things. Like you saw that one spell, like it had a whole bunch of like unique steps to it. And a good way to do that is by setting up your stateless resources to have kind of like functions that are meant to be overridden. So you can see here this passive weapon modification has a couple of these functions here called like on attack, on hit, and on crit, and they don't do anything. Not for like baseline at least. But they're passing a bunch of stuff. But for a weapon mod that does something with one of those, you can override it. So you can see here that this thermal charge weapon mod extends passive weapon mod, and it overrides this on hit activation. And so in all other respects, it acts just like a normal passive weapon mod, but it does like this specific stuff on hit. And so that's kind of like how I've been organizing and making all of these different abilities. And again, the important thing is that it's stateless. Like it's never gonna like mean say, or everything that has this ability is always gonna point to this single resource. Okay, so the next layer that I want to talk about is this middle layer, the persisted resources. So if the stateless ones don't like know anything about like the individual units that are going to be using it, this is kind of like where the soul of your units are going to live, or other things. And so here's an example, one of those. This is what I've been calling kind of like a unit core, because I always think about these things as like cores, where it's like, okay, you can like pop out this core out of like a robot or something and go plug it into another one, and it's the same robot. And so as you can see here, it's just like a whole bunch of export variables, like names, like what templates it has, like what faction it's part of, anything that like you want to persist and be able to like bring across multiple maps. And Godot is really nice, where like when you set up a resource with a whole bunch of export variables, it's very easy to just serialize it and say like, just give me a text resource that represents this specific unit. And you can have a whole bunch of different unit cores for like different configurations. And so it can also be like more temporary resources. So like this is one of these like stateful resources that just say, that track everything about a unit over the course of a single battle. So this would be useful if you want to like save or load that same battle, even if like this wouldn't persist among like different scenarios. And then the last layer is like this kind of like earthy ephemeral nodes. And this is going to be almost everything that the player actually sees on the screen. And so you can see here, this is like one of these like unit tokens. So like you can plug in a unit core in a battle state, and it just updates itself based on those things every single time that you like tell it to. And so like it doesn't have any memory. Like you can just like give it a new core and state like every single time you want to re-render it, and it'll be totally hunky-dory with it. And it'll just run with it. And that's really handy for like if you want to create a whole bunch of them in different contexts, or like create them and then like throw them away. Just as long as you like keep those cores to do. And so it can also like represent different screens of your game. Here's just like all of the games like UI in a battle. And you can see it's just like a list of nodes here. So a kind of challenge that this structure presents is how do you have those stateless resources talk to ephemeral nodes? Like if they're up in like in the heavens, and they like don't know anything about your specific game, how can they like produce effects? And so my favorite way to do it is with this bus pattern. So this is a special type of singleton resource that just like is a big list of big old signals. I'm realizing that this is like really Godot specific, and I don't know how many of people in the audience are like into Godot. But yeah, I've been really loving it. And I just have been like looking for an excuse to like info dump about this for like a year. So y'all are my captive audience. Yeah, so this is like a bunch of signals. And the way that signals work is that they don't really like pay attention to what is listening to them. They just kind of like emit the signal, and anything that's like decided that wants to be connected to this can like then respond. So you can have these stateless resources know about this singleton kind of like a bus here. So here's a stateless resource over here on the left. It points at this single bus resource. And then you can just tell it to be like, hey, effect bus, play text. And then you just like emit the signal with like the stuff that you want to have happen. And as far as the stateless resource knows, like that's the end of it. It's like, oh, I assume that happened. Like I assume that some ephemeral node like saw that somewhere, spun up like a text particle resource, and it just like handled that. So that's really nice that you can kind of like detach what the player is seeing from like the logic of the game really cleanly. And yeah, so after like that signal gets emitted, if you have in the scene tree somewhere something that's like listening for that, so like this node here is like saying, okay, like I'm gonna pay attention to like, I'm gonna be in charge of like responding to that signal. When it starts up, it says, okay, whenever I hear the play text thing happen, then like put some text things on screen. And it's like, it's so satisfying to like have the view separate from the logic. Like the stateless resource doesn't care anything about the implementation. And that's really handy. However, it gets a little bit more complicated when you start wanting to respond to what the player is doing on the screen. And so it's like, back in this first example I showed of the passive weapon mod, when it hits something, it actually requires the player to say, hey, do you want to use this or not? Because it has a limited number of charges. And so that's where this fancy new thing that only Godot 4 implemented, called await, comes in. And it's very, very handy. It basically pauses execution of this logic until this resolves. It's beautiful. I love await. I made the whole demo in Godot 3, like pre-await, and it was just like a huge mess. And like then the game logic had to be connected to the view logic, and like everything that like wanted to know, like needed to have like player confirmation, needed to know like the component on the screen that was like responsible for that, and that's not a good place to be. So this kind of like await signal, and like then combined with like buses, allows you to like disconnect that. So again, in review, these are the kind of 3 layers. And a big advantage of this, just to like make this very clear about how nice it is to disconnect game logic from view, is I did an art test around December of last year, and I realized that the game looked so much better in 3D. So the top left here is the original 2D version that we had about 4 months ago, and the one on the bottom right is how it looks today. And for like a lot of games, like this might be like a huge increase in scope, but luckily, since I had been following this structure so closely, if like this was our game, these red areas are the only things I had to change when switching from 3D or 2D to 3D. I didn't have to touch anything up in the like save data or the kind of like abilities and stuff. Like for all they know like they're still playing a 2D game. This only works if you don't like change the mechanics between 3D and 2D. And in our case, like we really didn't have to. Like it really was just like, let's display this map, but instead of like awkwardly having these like weird gray areas of like raised elevation, just like let the player like rotate and like let things like be obscured, because like the player can just rotate the camera around it. So I felt very vindicated that it wasn't just preemptive optimization that would like never come up. This kind of thing is a form of defensive programming that can like help you kind of like withstand the like big changes that can come down the pipeline that you might not expect over the course of game development, and everybody has these things. And just lest you think that this is only applicable for like some like giant project like the one I'm working on, we've also been following this structure for the portrait maker section of the game, which like isn't really connected with any of the mechanics, so it gets its own graph. And you can see here that you have just the same like 3-layer structure, where down here at the bottom we have these like nodes that have like all the like different UI. Up here at the top we have different like slice types and like portrait slices. We were using like sandwich metaphors, which I kind of regret now, because like the words just like stop making any sense. But yeah, like a whole bunch of like different slices of a portrait, like eyes, hair, or like clothing and stuff get put together into a sandwich. And it like allows us to just like very quickly say, okay, we have just a whole bunch of different of these like sandwich nodes on the screen, and we can just plug in the same slice core and like even modify that slice core every single time we want to re-render. And it just like makes it very easy to make a whole bunch of duplicates of things that all are kind of like different expressions of the same data. So just we're in the like miscellaneous other notes that I didn't want to cut out portion of the talk. Other notes about implementing this sort of thing is that you're going to want some sort of library system to fetch your stateless resources. So it's very handy to be able to be like, okay, I want to go get that one specific ability somewhere in the file system. So like the ability that like gives you more armor or something. And so it's very handy to have like something go through and scan some folder that you put all this stuff in, and then like organize it into like, okay, here's all the campaigns, here's all the like effects groups or like a gear. Didn't mean to click there. And so like this is kind of like what my folder structure looks like here, where I have just like all of these different folders of these like stateless bits of content, stateless resources. And then I can just like ask the content library like, hey, go get me a like mech frame, go get me some mech gear. If you don't want to roll your own, I noticed in the asset library, there has recently been a package that looks like it does a lot of this stuff called Godot resource groups. Check it out if you're interested in implementing this and don't want to roll your own content library system. Another advantage to this system is that it lends itself to writing unit tests. Since all of your kind of like a game logic happens without nodes, you can just like create some like cores or like create some of these like abilities and say, okay, apply this to this thing, do something to it, and I expect that like it works. And it doesn't even have to like touch the screen. I don't have to instantiate any nodes. So like these unit tests run very fast. But if you want to test something that like is more involved in like involves more layers of your game, you can also do that. So here's a little GIF of our test library running, where it's just creating units in like different situations and then like using different abilities and making sure that it behaves as normal. So like if one of the abilities like adds a little bit of armor, it like runs a test attack and makes sure that armor was applied and as much damage was done as it might expect. And this has saved me so many times when I like refactor something. I don't have to like go and replay the whole game to be like, okay, like what edge cases is this gonna like mess things up? Because I have like a robust test library testing a lot of these different abilities. And that is my talk. Thank you everybody so much. And I really mean it. Thank you for letting me talk about Godot for 20 minutes or however long it's been. Time for questions. Does anybody want to talk about nodes and resources and stuff? Go for it.
So with it all being so like vertically interdependent, my first thought, you kind of touched on in the end, was just like, what was the smallest version of this that you could test to see if it was working?
So the question was, what is the smallest version of something like this happen that I could test to see that if it was working? Well, it kind of like, it depends on like which system I'm talking about. Like, I guess here's one where it's like, here's like a small subsystem that doesn't depend on any of the rest of the game, and we could just like run that. For this one, I mean, like the game's has like a lot going on. Like Godot is really nice about like letting you run specific scenes. And so like for sometimes like if I wanted to just test like, oh, does like this like unit token work or something, I'll make a node that has like an export that I can like put in the editor that says, okay, here, like what core should I apply there? And then I just like feed it something, then I hit run, and then it just like runs in that like little test scene and it has all the data it needs there. Does that answer your question?
Yeah.
Great. Anything else? Yes.
This is more of a game design question, but does, obviously you're working on this game because it's, a game system you love. Does working on all the nitty-gritty behind the scenes things where you distill this like big creative game system down into like almost like raw spreadsheet, type of logic, does that ruin any of it for you, or is it still like, can you still play the game and still feel the fun of playing the game?
Yeah, so the question was, in converting something like Tabletop Lancer, a game that I ostensibly played for fun at one point, down into like this, has that sucked the fun out of it? Hyperfixation is a great thing. And it like, this is actually the second time that I've converted this to like a digital system. I also made a digital dice roller and like character sheet for the game called Witch Dice. And I'm still going strong on it, so hopefully that doesn't run out for me. Yeah. The game's also like very like rules heavy, and so is, I'm sure, made me insufferable to play with. Where I'm like, that's not technically an attack, that's an ability that just does damage. Yeah, great, fun. Anything else? Uh-huh.
I'm just wondering if when starting building this, the engine or the system came first? Because I know with the Godot engine, like you were saying, it's really efficient at creating this system. Was that the reason you would go for Godot, or did you just have a previous bias to it, or like what? Was there anything about Godot in particular that made it so like this is the engine that I'm using instead of giving me your own frameworks?
So the question is, why did I choose to, like, was there any relation to picking Godot for this system? And unfortunately not. This whole project has been I want to learn Godot so I can go work on my other neuroscience game at some point, and it's just spiraled out of control. However, I did mention that I made a demo in Godot 3, and like that was really the like, okay, how does Godot work? And I made like a lot of mistakes and stuff, and I threw all that code away for this second version. This sort of thing, I think, also like really works when I know you're not supposed to do this, but it's like more of a waterfall approach than like agile approach, where it's like, I know all the game rules, I know that it's fun, it's been paper prototyped essentially to death for years, I just need to like represent it. Though like we have come up with like, and had to make changes to it as like time goes on, as part of the adaptation, and that's where like the unit testing really helps with it. I didn't want to use Unity because I am a hipster, and I was like, I want to use open source software. And so it just like corresponded really well. Yeah. Uh-huh.
Sort of a related question to that, but what would you say, in your experience, are like the main differences or advantages of using Godot over other engines you've used in the past?
So the question was, what are the big advantages to using Godot over other engines I've used in the past? Psych, I've not ever used any other engines. Or specifically, I've built my own engines, and I believe there's another talk about why you shouldn't do that and what that process is like. So I'm very excited to hear somebody else's pain in that area, because I've gone through that and it wasn't fun.
Great. Well,
Great.
thank you.
Thank you.